Example 4. Prove that the sum of 3 consecutive integers is a multiple of 3. So what I'm going to do first is I am going to write down n for my first number, n plus 1 for my second, and n plus 2 for my third. Now, why I'm using n plus 1, and n plus 2 is because, say example, n is my first number, say number 1. If I'm going to add 1 to that n, it will give me number 2, which is the second number. And if I add 2 to that n, it will give me number 3, which is my third number. So n is like my first number, n plus 1 is my second number, and n plus 2 is my third number, right? So this is what it means by consecutive integers. Now, we want to prove that the sum of it, so the sum of all of them, so sum basically means we're adding them all together. So we have n plus 1 plus n plus 2. So we have 1, 2, 3 n's, which is 3n. And then we have 1 plus 2, which is 3. So we're nearly there. We have to now factorize this expression 3n plus 3. And we can take out a 3. So we have 3 on the outside, n plus 1 on the inside. And this is a multiple of 3. Because we basically have a number on the inside, which can be any number, but it's always being times by 3. And anything times by 3 is in the 3 times tables. Right, so here's the last example. Example 5. Prove that the difference between 2 consecutive square numbers is always an odd number. So, first of all, I am going to figure out how we're going to show square numbers algebraically. And it's not that difficult. Firstly, we have an n, okay? And because it's a square number, it has to be n squared. So that's my first square number. Okay, so n squared, that'll be my first one. Now my second one will be n plus 1 squared. So it's kind of similar to the previous example where I have my first number being n and my second number being n plus 1. The only difference here is that this n plus 1 squared, I'm going to have to expand it. So n plus 1 squared can be written as n plus 1 in double brackets, like so. And then we just expand this. We do n times n, which is n squared, n times 1, which is n times 1, which is n, 1 times 1, which is 1, right? So this now simplified gives you n squared. You can combine the n's together to give you 2n plus 1, right? So we want to find the difference between the 2 consecutive square numbers. So difference means we're going to take them away. So we're going to take away this one from the first one. So we'll just do that now. So n squared plus 2n plus 1 subtract n squared. And that would equal the n squareds, they disappear, they go bye-bye. So we have 2n plus 1. And funny enough, from what we looked at earlier, this is always odd.